Hello grade 11s, welcome back to our second video lesson. So we're just going to start off by going over the corrections for question number 2 and question number 3, and then we're just going to continue working through some combination circuits. Okay, so I'm just going to divide this portion into 3 so that we can work through it. I think I'll just need a little bit more space than that. Okay, so it says calculate the current I1 and I2 in the following circuits. Assume that the cell is identical for each circuit. Okay, so essentially they are asking you to calculate what you think the total I1 and I2 is going to be. So it says that the cell is identical. Notice that there is only one cell in each of these circuits, and it says that they are identical, which means that they all have the same voltage. Now you don't know what that voltage is, so your first step is going to be to figure out what that voltage is. Now notice for the first circuit, I have the current and I have the total resistance, which is just the 2 ohms. So I can figure out V total. So I can say, well, we'll call this circuit 1, circuit 2, and circuit 3. I can see for circuit 1, all I have to do is just calculate the voltage. So I can say, well, V is equal to I times R. I can see that the current is going to be 1, 2, the resistance is 2, which means the total voltage is just going to be 2, 4 volts. Now that means that this one also has 2, 4 volts, and so does this one. So now the current they want you to find is obviously going to be the current for all the total current. So for circuit 2, I can say, well, the total current is going to be equal to the total voltage over the total resistance. Now I can see, well, the total voltage is the 2, 4 volts. Now the total resistance I don't know, but I do know that to calculate R total for a series circuit, it's going to be equal to 2 plus 2, which is just 4 ohms. So now I can put that in the calculator and I get the total current to be 0.6 amps. Okay, so now it says that you need to calculate I2. So if I look at I2, I see, okay, well, again, I have the same issue. I have the total voltage. I need to figure out what the total resistance is. So I can see, well, R total is just 1 plus 5, which is 6 ohms. Okay, again, it's just a series circuit. So then I know, okay, well then, if I is equal to V over R, I know the total voltage is 2.4. The resistance here is 6. So if you put that in your calculator, you should get an answer of 0.4 amps. Okay, that's for I2. And this one's for I1. Okay, and that's it for number 2. Then for number 3, it says calculate the value of the potential difference for resistors A to E and cells F and G. Okay, so let's have a look. We'll label each circuit. So we'll label this circuit 1, and then we'll label this one circuit 2, circuit 3, and circuit 4. Okay, so for circuit 1, we need to calculate the 3 ohms, the 2 ohms, and the 1 ohm. So notice that in this circuit, I can see that all three resistors are connected in series with one another. So they said they want to know the potential difference across this one, across this one, and across that one. Now, in order for me to find the potential difference of each one, I need to first find out what the total current is. Okay, because that's what I'm missing. So I can see, well, in order to do that, I'm just going to say, well, current again is equal to the V over R, but now I'm looking at totals. So V total, I can see 6, and R total is just going to be 3 plus 2 plus 1. Okay. So all of that together will give me 1 ampere. So I can use that and I can say, well, now I can calculate the voltage through each one. Okay, so there's two ways that you can do that. You can either say, well, there's A, B, and C. That's V is equal to IR. Which will just be 1 times 3, 1 times 2, and 1 times 1. Which will be 3, 2, and 1 volts each. And notice that when you take them all together, it should give you 6 volts. Okay, so that's for number 1. Then the second circuit, we are trying to calculate the voltage again for these two. Now again, we're going to need to find the total current again. So I'm going to say, well, the total current, I'm going to use the same equation. Sorry, let me just fix this. So I can see, well, total current is again just going to be V over R. I see the voltage is 18. And the total resistance is in series, so it'll just be 4 plus 5, which is 9. Which will give me a total of 2 amps. Now I can take those 2 amps and I can say, okay, well, I can calculate now D and E, because V is equal to IR, which is equal to 2 multiplied by 4 or 2 multiplied by 5, which would then give me a total of 8 volts and 10 volts. And notice that they should both give you 18. Okay. Moving on. So now for the next one, I can see, well, the third circuit, they said they want to know F, which is the cell's voltage. So essentially they want me to find V total. So notice that I know that there's 1 volt that goes through here. So I can calculate then the current because I have 1 voltmeter reading and 1 resistor reading. So I can say, well, I can do the current that goes through the 2 ohm resistor. So the current through the 2 ohm resistor is going to be equal to V over R, which is 1 over 2, which is 0.5 amps. Now, if you can remember from our previous discussions, we said, well, the current is equal in a series circuit. So if there's 0.5 amps going through the 2 ohm resistor, then it goes through the 3 ohm and the 1 ohm. So that's the total current. So now I can just use that and I can say, well, I know that V total is equal to I total times R total, which will be 0.5 multiplied by the total resistance. Now again, it's just a series circuit, so I can say 2 plus 3 plus 1, which is just going to be 6 ohms. So I can take that, put it in the calculator, and you'll get 3 volts. Okay, so that is the voltage at F. Okay, now the next one, we're calculating G. So I know that this is going through 1 volt. But I also know that the current, the voltage that is going through this one is going to be the same, which is equal to the total voltage. So you can go through the effort of calculating it, but it's not necessary to calculate the total current because the voltage is equal. So the V of G is just going to be 1 volt. Okay. So the reason why that is the case is because the total voltage here is the voltage that's across from, if I put a voltmeter here and I took it all the way to this side, it's going to be equal to the total voltage because this is the total resistance. Now if there was a resistor here, which we'll do in the combination circuit, that's a different story. But here we can see, well, the voltage is equal here, which is equal here, which is equal over the whole thing, which is the total. Okay, so just make sure you think about that. Okay, moving on now to combination circuits. So now we're going to be looking at combination circuits, and the date would be the 6th of May. Okay, so when we read this question, we notice that it says the batteries of each of the following circuits have no internal resistance. Okay, so what that means is, it means that there isn't any sort of resistance that we have to worry about inside the battery. Okay, that's only going to become an issue next year. Okay, so it says, and the light bulbs are identical. Okay, so that's quite an important little note there, because then we know that their resistances are going to be the same. Okay, so it says the light bulbs each have a resistance of 5 ohms, and the potential difference across the terminals of each battery is 12 volts. Okay, that wasn't put in the diagram, so let's go ahead and put that in. So we know that it's 12 volts here and 12 volts here. Okay, so it says, for figure 1, calculate the current through each light bulb. Okay, so this, I can see that the resistance, the total resistance is in series. So all I have to do is just then calculate it by adding the resistance. So I can say, well, R total is going to be equal to 5 plus 5 plus 5, which is going to be 15 ohms. Okay, easy enough. Then I can see, well, the total current going through each resistor will equal to the total voltage over the total resistance, which is just 12 divided by 15, which is going to be 0.8 amps. Okay, then it says for figure 2, calculate the current through each light bulb. So this one's different. And the reason why is because if you notice, there is a resistor that is in series, and the light bulbs are in parallel to one another, which means that the current that runs through this portion of the circuit is different to the current that runs through that portion of the circuit, because remember, in parallel, okay, current is split, so there's going to be a split of the current here. So we have to keep that in mind. So the first thing we need to figure out is what is we can calculate the total current, can't we? I total. By saying, well, I total is equal to V total over R total. So the goal then is to get R total first, because we have V total is 12 volts. So we'll say I total is equal to V total over R total. But R total is going to be equal to the parallel portion plus the series portion, because this parallel component acts as one resistor. So if I can calculate the R here, then I can just add it to the R here, because you can see that these two are in series with one another. So let's say, well, if I calculate the R parallel part, I can just add that to the 5 ohm resistor. So the R parallel part is 1 over 5 plus 1 over 5 to the power of negative 1 plus 5, which is just going to be equal to 2, 5 plus 5, which is 7, 5. So now I can take that and I can say, okay, well, then I know that the V total is 12 volts, the R total is 7, 5 volts, which means that the current is going to be 1.6 amps. So 1.6 amps is the total current that goes through the total current here. But the current through the light bulb is going to split. Now you can do the calculations, but something that's quite easy to see is that this light bulb and this light bulb are equal to one another, which means the current is going to split equally. So if the current splits equally, then through the bulbs, the current is just going to be 1.6 divided by 2, which is 0.8 amps each. The only reason why we were able to do this, to divide by 2, is because if I look at this, I see, well, the resistors are identical. Okay, if they weren't identical, so if this is 5 and this is 1, then you can't divide by 2. It won't split equally. So it only does this because it splits equally. Because the resistance is equal. Okay, so just take note of that's the only reason why we were able to do it like that. Okay, moving on to number 6. It says, refer to the following diagram. The resistance of the conducting wires and cells are negligible. Calculate the resistance of the parallel connection. So again, you notice that you have resistors that are in series and you have a resistor that is in parallel. So it's always important to work out the parallel component on its own before looking at anything else in the circuit. So in this case, they actually say calculate the resistance of the parallel connection. Okay, so that's quite easy to do. We can say, okay, well, R parallel is equal to 1 over 6 plus 1 over 4 to the power of negative 1. You can put it in your calculator and you'll get an answer of 2,4 ohms. Okay, so then 6.2 says calculate the total resistance in the circuit. So now I know, well, this part now acts in series to this and to this. So now I can say, well, then R total will be equal to 2,4 plus 3 plus 7, which is just going to be 12,4 ohms. So all we have to do is just add them together And once we know the total resistance here, then it just acts like a parallel, like a series resistor. Okay, and we do that always with combination circuits. So 6.3 now says calculate the total current in the circuit if each cell has a voltage of 1.5 volts. So it says each cell. So it's very important that we look and we say, okay, well, we need to calculate then how many cells there are. So I can see I have 1, 2, 3, 4 cells. So 4 cells, the total voltage then is going to be equal to 4 times 1.5, which is then going to be 6 volts. Okay, so I know that the total voltage, V total, will be equal to 4 times 1.5, which is 6 volts. So if they want to know the total current, then I can just use Ohm's law and I say, well, I total will be equal to V total divided by R total. V total is 6 divided by the total resistance I just found to be 12.4. So I put that on my calculator and I'll get an answer of 0.48 amps. Okay, so it's important just to break the circuit up into doing the parallel portion first, and then once you know the resistance here, then it's just a series circuit. You'd have R4 plus R1 plus R parallel, which would then act as one resistor. Okay, then it says calculate the current flowing through each parallel resistor. Okay, so you have to calculate how much current is flowing on this side. So what I'll do is I'll split it up so we can see it, because if you notice the resistances are different, which means that the current that goes this way is going to be different to the current that is going that way. Okay, so the way we work this out is there are different ways that you can do it. So firstly, we need to figure out what is the voltage that goes through this, because if I know the voltage, I can calculate the current. What's important to remember is that the voltage that goes through here is the same as the voltage that goes through here. So this voltage I need to work out. So I can do that because I know what the resistance is for this entire portion, and I just found I total. So I can say, well, I know that the voltage over the parallel component is going to be equal to I multiplied by R. Now the I that goes through it is still going to be the total current, 0.48. So although it splits, the current that goes into the parallel and out of the parallel is still going to be 0.48. Then the total resistance there, we worked it out to be 2,4. So then you'll just put it on your calculator and you'll get 1.15 volts. So now you know, okay, well, the voltage is equal in a parallel circuit. So the voltage that goes through here is equal to the voltage that goes through here. So I can calculate current again using my Ohm's law formula. So I can say, okay, well, the current through R2 is equal to V over R. I can see that R2's resistor is 6 ohms. So I can say, well, it's 1.15 divided by 6, which is just going to be 0.19 amps. Okay, and the current that goes through R3 is V over R, which is going to be 1,15 divided by 4, which is just 0.29 amps. Notice that if you took these two currents together and you added them, they should give you the total current, which is the 0.48. Okay, so take note of that. That's something that's quite important to notice. Okay, something that you could also have done is resistors, the current splits according to the ratio of resistors. So if we notice the ratio here between R2 and R3 is 6:4. So this is just another method that you can use where we use the ratios of the resistors, which can sometimes come out in a question. So it's quite good to know this method as well. So the ratio of R2 is to R3 is 6:4. Now if you understand how ratios work, is we know that the current that goes into the parallel component is 0.48 amps. That's the total current. So I can divide this into the ratio 6:4. And you do that by saying, okay, well, 6 plus 4 is 10. So you would say 4 over 10 multiplied by 0.48 would give you 0.192. And 6 over 10 multiplied by 0.48 will equal to 0.288 amps. And then you have the current, because it splits according to the resistance, the ratio of resistance. So notice that both methods get you to the exact same answer. Okay, so just take note, you can make a star of this, that this is quite an important method for you to know, because it can still be used, and you can also use this method, and it can come up in like multiple choice kind of questions. So don't just ignore it or leave it. Okay. Then 6.5 says calculate the potential difference across each of the resistors. Okay, so let's have a look. So basically I'm trying to find the V across every single resistor. Now I know that these two will be the same. So it's the R1 and the R4 that is going to be different. So let's have a look and see. We'll start with R1. So the voltage V1 will be multiplied R total multiplied by R1, which is 0.48 multiplied by the resistance of R1, which is 3. So the voltage through that one would be 1,44 volts. So all you do is you take the current multiplied by the resistance, and the current that goes through the 3 ohm is the same as I total. Now the current through the 3 ohm is the same as the current through the 7 ohm. So I can figure out that one by saying, well, the voltage through resistor 4 is also equal to I times R4, and I is I total multiplied by 7, which is just going to be 3,36 volts. Okay, then the voltage through the other, through the parallel component, we technically already found it here. So you don't have to necessarily do it unless you used this method, then you would have to calculate the voltage again. But the voltage through the parallel component is equal to 1.15 volts, which means that you must state that V through R2 is 1.15 volts and the V through R3 is also 1.15 volts, because they are equal. Remember that potential difference in a parallel circuit remains the same. And notice that you should be able to add this. If you take 1.44 plus 3.36 plus 1.15, you should get to the total voltage, which is going to be 6 volts. So you've done it correctly if you can make this statement. Okay, remember we don't add 1.15 twice because that's for the parallel part. So we take the V parallel. We don't take the individual voltages in the parallel component. Okay. Then it says calculate the charge. Okay, so this one's Q. Okay, so it's important to now remember Q is in those formulas that we use to describe the definitions of current and voltage. So we need to use that. It says through a single 1.5 volt cell, okay, so we have V, if it supplies 300 joules of energy. Now remember I said earlier that energy is the same as work. Okay, so don't get confused and think, oh no, I don't know what energy is. It's the same thing as work. So this formula, Q, V, and W, is the potential difference formula where V is equal to W over Q. So they want Q, so you can say, well, therefore, Q is the same as W over V. Okay, which is just going to be 300 joules divided by 1,5 volts, which is 200 coulombs. Okay, that's the charge that flows through the 1.5 cell. Then it says calculate the time taken for the charge to flow through a cell. So time and charge is the current formula. I is equal to charge over time. So time will equal to charge over the current. Okay, which is going to be the 200 coulombs divided by the total current. Now the total current was 0.48. So you put that on your calculator and you get 416.67 seconds. Okay, so that's how I would calculate these questions from question for the entirety of question 6. So the most important thing is just to remember how you treat your parallel portion compared to your series portions, and to remember these notes that we went through before this video lesson. You must know that this happens in the series circuit for the current, the voltage, and the resistance, and you must know that this is what happens to the resistance, current, and voltage in parallel. Okay, the only way that these become easier to understand is through practice, 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 practice. Okay, you cannot, it's not something that you'll just understand, it's something that you have to develop over time and keep practicing and practicing. Okay, so your homework is going to be from this exercise. I want you to complete question 7 until question 11. So it'll be question number 7, number 8, 9, number 10, and 11 is just a multiple choice. Okay, please, like I said, it's all about practice, practice, practice. So you have to practice this. Okay, and then I'll go over the corrections in our next lesson. Okay, so please make sure you go over these questions again. If you struggle to understand them, I recommend that you practice on your own and then go through the answers that we went through. And yeah, good luck, and I will see you on the next one. Bye-bye.